About 150 million years ago, Earth's most recent supercontinent was in the process of breaking up. Sauropods dominated the lush, slowly separating landmass that would become today's familiar continents. Meanwhile, in the asteroid belt, a breakup of a different sort was taking place. The large asteroid 163 Origone was pummeled in a collision, shedding debris to form a new family of asteroids. Fast forward to 3.2 million years ago, long after the fall of the dinosaurs, when an early hominin walked upright through an Ethiopian river valley. Now, a robotic explorer named for our most famous human ancestor is heading to a member of the Origone asteroid family, en route to the fossils of planetary formation.
Liftoff. Atlas V takes flight.
NASA's Lucy mission launched in October 2021 and flew past Earth in 2022 and 2024 for a pair of gravity assists. In early 2025, Lucy entered the main asteroid belt, on course for humanity's first encounter with 52246 Donald Johanson. The asteroid was named in honor of the paleoanthropologist who discovered the Lucy fossil in 1974, rewriting the textbooks on human origins. While asteroid Donald Johanson has never been seen up close, its brightness varies greatly as it rotates, suggesting an elongated shape. It is a member of the Origone family of asteroids, made from fragments of the collision that took place about 150 million years ago. Earth-based observations suggest that Donald Johanson is carbon-rich, has an average diameter of about 4 kilometers, and spins on its axis extremely slowly, giving it a 251-hour day. On Sunday, April 20th, Lucy will approach Donald Johanson from the direction of the Sun, traveling 13.4 kilometers per second relative to the asteroid. As its target grows near, the spacecraft will slowly rotate, keeping the asteroid in view. Over the course of a few hours, Donald Johanson will transform from a point of light into a detailed world. Lucy's long-range reconnaissance imager will capture high-resolution pictures throughout the flyby, providing our best look yet at the asteroid. Just before closest approach, when Lucy is about 900 kilometers from its target, it will abruptly turn its instrument pointing platform away from the Sun to protect its sensitive electronics. Shortly after the flyby, Lucy will perform a pitchback maneuver, changing the direction of its rotation to turn its high-gain antenna toward Earth. 2 hours later, data from Lucy will deliver the first close-up views of Donald Johanson, a surviving remnant of the solar system's chaotic past. Following the flyby, Lucy will continue to pass through the main asteroid belt. In August 2027, it will reach Euripides, an asteroid more than 10 times larger than Donald Johanson and a member of the Jupiter Trojans. These primordial and primitive objects are trapped in Jupiter's orbit and are considered the fossils of planetary formation. Between 2027 and 2033, Lucy will make 5 separate encounters with Trojan asteroids and their moons. It will become the first spacecraft to explore this ancient population, asteroids more than 1,000 times older than our most famous human ancestor, formed at the dawn of the solar system, long before dinosaurs ruled the Earth.
From astronaut servicing missions to breathtaking images, from science proposals to science papers, Hubble's got the numbers. To begin with, this space superstar is 43 feet long and 14 feet wide. That's about the size of a big yellow school bus. Hubble weighs 27,000 pounds, heavier than 2 full-grown elephants. Now, imagine this giant beast orbiting Earth about 300 miles up, zipping around at a jaw-dropping 17,000 miles per hour. That's like traveling from New York to Los Angeles in less than 10 minutes. Every 95 minutes, Hubble completes a full orbit around the Earth, giving it a front-row seat to the wonders of the universe. In fact, since its launch in 1990, Hubble has traveled over 5 billion miles, going around our planet over 190,000 times. Powering this cosmic giant are its solar arrays, generating over 5,000 watts of electricity. That's used to power the hardware on Hubble and to simultaneously recharge its batteries that are used when Hubble is in the shadow of the Earth. Hubble's hardware, which includes everything from computers to cameras, uses a total of 2,100 watts of electricity. That's enough to power 210 LED light bulbs. Hubble's optics feature a 7.8-foot primary mirror that is polished so smooth that if you stretched it out to be the width of the United States, you would never find a bump higher than 6 inches. Hubble has two 16-megapixel cameras. This allows Hubble to capture the universe in stunning detail, taking us from our moon 240,000 miles away to objects in our solar system millions of miles away, to galaxies hundreds of millions of light years away, and even to some of the farthest galaxies around 13.4 billion light years away. In fact, Hubble's mirror collects light 40,000 times better than the human eye. This system is so powerful that Hubble can spot a nightlight on the moon. To keep Hubble at peak performance, astronauts visited 5 times to service the telescope. These missions included essential upgrades and repairs that extended Hubble's life and modernized its technology. From installing new cameras to replacing gyroscopes, each mission was a complex, high-stakes endeavor. In total, 32 astronauts have flown to Hubble, and with 5 servicing missions combined with 171 hours of spacewalks, these brave men and women went above and beyond to ensure our window to the universe remains crystal clear. Hubble has over 1.6 million observations that resulted in more than 22,000 peer-reviewed scientific papers published in professional journals on its discoveries. Those papers have been cited in other papers over 1.3 million times. That's a lot of cosmic knowledge, all because of one space telescope. Hubble's groundbreaking discoveries revolutionized our understanding of the universe, from measuring the rate of its expansion to finding evidence of black holes and even peering into the atmospheres of planets around other stars. Even with so many observations over 3 decades, Hubble has still only observed around 0.1% of the entire sky. That means Hubble has a lot more of the universe to explore. So the next time you gaze up at the night sky, remember that Hubble is out there, unveiling the secrets of the cosmos. Over its more than 3 decades in orbit, we really have learned a lot about our place in the universe, thanks to one incredible telescope.
The oceans. They are always on the move. Together, the ocean basins are like a big interconnected highway that transports nutrients, carbon, and heat around the world. This mesmerizing data visualization of ocean currents was created using a model called Estimating the Circulation and Climate of the Ocean, or ECHO for short. It's built using real-world data from satellites, buoys, and all kinds of other measurements. All of this movement starts with physics. Because the Earth is spinning, the water feels something called the Coriolis effect. This pushes some of the strongest currents, like the Gulf Stream and the East Australian Current, against the east side of the continents. Because these currents wind up on the west side of the ocean basins they sit in, scientists call them western boundary currents. In this visualization, the currents closer to the surface are white, and the deeper currents are blue, almost like you're seeing those deep currents through the top layer of water. But what's causing all this motion? And what makes some water rise and some water sink? Let's take a look. Here we can see the Pacific Ocean's strongest current, the Kuroshio. It begins in the warm tropical Philippine Sea and then flows north past Taiwan. After it reaches Japan, it turns east and heads across the Pacific Ocean, spinning off huge eddies where it turns right. The Kuroshio carries over 200 times more water than the world's largest river, the Amazon. This visualization makes it easy to see how the ocean moves water across the planet. But what's hard to see are the places where the water moves up or down. This is called upwelling or downwelling. When upwelling brings cold, deep nutrients into the sunlight near the surface, it creates a feeding ground for all sorts of ocean life. Nutrients, carried in part by the Kuroshio current, help feed the fisheries in Japan and create an important economic zone for the country. Another major western boundary current is the Agulhas current, which carries water down the east coast of Africa to its southern tip, called Cape Agulhas. There, the current makes a sharp turn to the east, but sometimes it pinches off giant eddies called Agulhas rings, which drift west into the Atlantic. These circular currents carry salt and heat into the Atlantic and form an important part of the overturning circulation, also known as the global ocean conveyor belt. This so-called conveyor belt is a system of currents that carries heat northward across the equator and into the North Atlantic. It plays a big role in the climates of North America, Europe, and Africa. Without it, winters in Europe would be much colder and droughts in Africa more severe. But the oceans do more than just move heat around. In some places, they absorb heat from the sun, and in others, they release it back to the air. We can see that in the Gulf Stream. Yet another part of the ocean's conveyor belt, the Gulf Stream starts in the tropics, where the water is very warm. As it drags warm water up the east coast of North America, it acts like a heater for the atmosphere. By the time this water has wandered across the Atlantic and wrapped around Europe, Iceland, and Greenland, it's gotten so cold that it sinks deep into the North Atlantic Ocean. But temperature isn't the only thing that can make water sink. So can salt. Salinity, or the amount of salt in the water, can make it heavy. The saltier and colder water is, the heavier it gets. As it gets warm and fresh, water gets lighter. Changes in the heaviness or density of ocean water are what keep the ocean's conveyor belt turning. The streaks you see near the surface show how water is moving from one place to another. But if you look closely, you can see that deep down, water is moving in a different direction, sometimes even the opposite direction, like it does far below the Gulf Stream. This cold, deep water headed south beneath the Gulf Stream is another part of that same ocean conveyor belt that keeps Europe warm. Some of that warm Gulf Stream water that heads north at the surface eventually winds up there, moving south again after losing so much heat to the atmosphere. Eventually, this cold, deep water will spread around the globe and slowly rise toward the surface. There, it will warm up in the sun and get ready to start the trip all over again.
The great thing about a lunar eclipse is that you don't need special equipment and you don't need to be in a particular location. Everybody in the United States is going to be able to see this. They just need to go outside and locate the moon. So a total lunar eclipse happens when the sun, the earth, and the moon are aligned. The moon goes around the earth once a month, but we don't get an eclipse every month because the moon's orbit is a little bit tilted. We get that alignment about every 6 months, and so the Earth's shadow stretches across 240,000 miles and lands on the moon. Eclipses don't happen every month because the moon's orbit is tilted by about 5 degrees, and so some months during the full moon it's going to pass a little bit above the Earth's shadow, and some months it's going to pass a little bit below. About once every 6 months it actually passes through the Earth's shadow. Now, it doesn't hit the middle of that shadow every time, so some lunar eclipses are just partial. But every year or year and a half, we get a total lunar eclipse where the moon passes through the center of the Earth's shadow, and every part of the moon is blocked from the sun. The best thing about a lunar eclipse is that it's beautiful. So the moon during totality will turn shades of orange and red and brown. It's being hit by all of the sunrises and sunsets projected from the Earth.
We cannot eliminate fire, nor do we want to. Wildland fires are a natural and essential part of ecosystems on our landscape. In 2023, the National Interagency Fire Center reported responding to 56,580 fires, which amounts to about 2.7 million acres burned in the United States. And this impacts communities, public health and air quality, and ecosystems. Surprisingly, one effective method to mitigate future severe fires is to use fire to combat fires. Both prescription burning and unplanned fire ignitions, like lightning-caused fires, under the right fire weather conditions, reduce fuels for future fires that might burn more intensely under hotter and dry conditions that we cannot control. Fires clear understory growth, the grasses and the fuels and the brush, and this promotes new plant growth, benefiting both the ecosystems and wildlife. Change, including fire, is vital for forest health, and many species depend on it.
It's crucial for us to further our understanding of fire. At the Rocky Mountain Research Station, we use the latest technologies to study fire. Using the latest data sets from partners like NASA to map vegetation, fuels, and past fires helps researchers to model fire spread, risk, and severity. Building tools, models, and applications that fire managers can use to make decisions, often under rapidly changing conditions, that restore fire to the landscape in the appropriate ways, times, and places, reduces the risk and severity of future fires.
At NASA, we employ various methods to collect near real-time fire data. This includes aircraft and ground-based campaigns. One distinct approach is by using satellites, we have a global view of fire. With this perspective from space, scientists can accurately locate thermal anomalies or fires, their spread over time, and monitor vegetation conditions.
Fire managers have to make complex decisions. These data sets and scientific approaches help teams predict how fire will evolve over various different scenarios and foster collaboration within fire-affected communities.
Satellite observations give us an eye in the sky during an active blaze and also allow us to track fire behavior trends over time, providing those on the ground with the data they need to make complex decisions and bringing fires safely back to our landscapes.
Forest Service research and NASA datasets help us to move to more proactive fire management that promotes healthy forests and watersheds while simultaneously reducing the risk and severity of future fires.
In 1958, scientists put a vision that we need to fly a spacecraft within the atmosphere of the sun. But it is so challenging, extremely difficult to realize, that it took us 6 decades to build a system that can fly safely and reliably within the atmosphere of a star.
3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
It looked like we had a hit there for a second.
Yes, Nick. I believe we do have a detection of beacon tone 1.
There it is. See it? There it is.
Parker Solar Probe is
3.8 million miles from the surface of the sun.
It is so incredible to just realize this is the moment that we designed this mission for. 3.8 million miles may not sound that close, but if I put the sun and the Earth 1 meter apart, Parker Solar Probe would be 4 centimeters from the sun. It's the closest human-made object to a star and also the fastest, traveling at 430,000 miles an hour. I mean, we're flying through the atmosphere of a star. That's not easy to do. It's something we've never done before.
This is our first close encounter with a star, and it's really just amazing. This area that Parker is going into is just so crucial to our understanding of the sun and its impact on the Earth.
That solar interaction, that space weather, those billions of tons of material that the sun can throw at us interacts with our power grids, can interact with our technology. So it's really important to understand them at their source and how they get all that energy.
When we were thinking about designing a spacecraft to go to some place that had never been before, and it's actually going there to study the sun, and so you're kind of saying, what am I designing? What are the environments it's designing for?
It has to go from the deepest, coldest space to a very warm area and keep everything working at a little bit above room temperature.
It's designed to go to such an extreme environment. You look at it and it doesn't quite look like most other spacecraft. The whole thing is designed such that the heat shield is taking most of the brunt of the heat of the sun. The heat shield will be at about 1,800 degrees Fahrenheit, and it's protecting the spacecraft. So the spacecraft's actually basically at room temperature.
This is such a great feat of engineering, and it really shows how capable we are in space.
This is something that we've been wanting to do since 1958 when it was first mentioned, and the technical problems that had to be overcome in order to achieve it is just monumental to be able to get a spacecraft this close to the sun.
To get close to the sun is not easy. It looks like from Earth to the sun, not that far. The key issue is energy. In order for Parker to get close to the sun, we needed to lose a lot of Parker's speed possessed at Earth's orbit. Fortunately, I was able to create a trajectory with 7 Venus flyby.
The mission uses Venus in order to actually change its angular momentum and slow down to actually go closer and closer to the sun.
Over the course of about 6 years and the 7 flybys, we were able to move closer to the sun, and each time unraveling a little bit more of the mysteries of the sun as we get data from places that no spacecraft has ever been before.
It's the only star in our galaxy that we can actually go visit, and that's what makes it so magical.
By flying within the atmosphere of the sun, we are basically tracing the fingerprints of the physical mechanisms of the sun. We now view the sun in a different way. When you look at images from Parker Solar Probe, oh my goodness, they are extremely, extremely complex. And that complexity, for us, it's a new science that we need to investigate, we need to understand.
The things that we've learned over the years that Parker has been in orbit have been amazing. They've challenged our ideas about how the solar wind is made, about how the sun works, about some of these fundamental things that are going on.
There's a lot of pride and excitement for this closest approach. So much effort and so many people have worked on this.
I think it really took the teamwork and synergy of engineers and scientists and administrators and a lot of different people to think this mission up.
It makes you think that you can basically overcome any hurdles. So dream big and go out there and make them happen.
What you're seeing here is a model, specifically of carbon dioxide moving through the atmosphere, driven by wind patterns and circulation. To create this model, billions of data points informed by data collected from satellites and ground-based measurements were run through powerful supercomputers to scale observed behavior to a global stage. What makes this model stand out is that it's super high resolution, 128 times higher than a typical weather model and 500 times higher resolution than a typical climate model. This means we could focus on individual points like power plants and forest fires and see in extreme detail how these plumes move and get mixed in the atmosphere. Now, why is this important? Because by creating these high-resolution models, NASA scientists are able to better understand the behavior of Earth's interconnected systems, like how plumes of CO2 interact and spread with weather systems. For instance, you can clearly see the impact the day-night cycles have on CO2 emissions. This is due to daily fluctuations in human activities, cycles of photosynthesis, and fires flaring up and dying down. Our ability to run such a simulation allows us to see how individual data points influence the larger picture, uncovering previously unknown atmospheric relationships, and help us better understand the complexities of our atmosphere.
What do this California lake bed and this rock on an asteroid have in common? Although they're located on radically different worlds, they both contain minerals that formed in environments that may have assembled the building blocks of life. For over a year, scientists have been studying the material gathered by the NASA OSIRIS-REx mission from the asteroid Bennu, and one of the many things they found are tiny crystals of a mineral called trona. Trona is a mineral known as an evaporite, meaning it is deposited when a briny lake evaporates, leaving behind all kinds of salts, just like in the salt beds of Searles Lake, California. Finding trona and other evaporites tells scientists that the Bennu samples once held pockets of salty, room temperature water. And that is just the kind of environment perfect for forming organic molecules, the building blocks of life. Scientists found organic molecules in the Bennu samples, including compounds that are important to building life. These findings and others gathered from the asteroid samples suggest that Bennu is a fragment of a once wet world, likely including material from beyond Saturn's orbit that existed about 4.5 billion years ago. Finding these ingredients supports the theory that asteroids like Bennu dispersed water and the chemical building blocks of life throughout our solar system and beyond.
NASA's Parker Solar Probe is about to make history. On December 24th, it'll pass within 3.8 million miles of the sun's surface while traveling faster than any human-made object in history. And we want you to join in on this historic event. Each day from December 17th to the 24th, we'll hide a prize on a secret webpage and share clues across social media to help you find it. solve the clues to win your prize. But hurry, and you can also claim glory. Clues drop at noon Eastern Time each day, and at 9 p.m. Eastern, we'll share the leaderboard showing who solved that day's puzzles the fastest. Then, on December 27th, when Parker phones home for the first time, letting us know it survived the sun's intense heat, we'll release a final leaderboard showing who solved the puzzles fastest overall. Are you ready for the 3.8 challenge?
Astronomers have been observing Jupiter's Great Red Spot, a massive storm big enough to swallow Earth, for over 150 years. However, new discoveries continue to emerge, especially with NASA's Hubble Space Telescope taking close-up views. Hubble's latest observations, gathered over 90 days from December 2023 to March 2024, show that the Great Red Spot is less stable than it seems. The data reveal that the Great Red Spot is wobbling like a bowl of gelatin. Hubble's images allowed astronomers to create a time-lapse movie of the storm's squiggly motion. While scientists knew the storm's position changed slightly over time, they didn't expect to see its size fluctuate. Thanks to Hubble's high resolution, they found that the Great Red Spot is squeezing in and out while speeding up and slowing down. Hubble observes Jupiter and the other outer planets yearly through the Outer Planet Atmospheres Legacy Program, or OPAL. But these particular images were part of a special Great Red Spot study. The team has been tracking the shrinking Great Red Spot since the OPAL program began 10 years ago, and predicts it will continue to shrink and eventually take on a more stable, less elongated shape. Researchers hope that future high-resolution images from Hubble might reveal other clues about what's causing the storm's fluctuations. Studying the biggest storms in our solar system helps scientists understand hurricane patterns on Earth, and could even apply to weather on planets around other stars.
This is the Endurance rocket ship, and she's about to discover something incredible and fundamental about the Earth. So why here? What makes Earth this special place that we all call home? One of the reasons may be due to the energy fields that our planet creates. So the first one's gravity. You're very familiar with gravity. It's important for life because it's holding our atmosphere on. If you don't have enough gravity, your atmosphere tends to escape to space, like at Mars. The second field is the magnetic field. It's this shield that's protecting our planet from the stream of particles that comes from the sun. So our rocket has discovered and finally measured number 3. It's called the ambipolar field, and it's an agent of chaos. It counters gravity and it strips particles off into space. Whenever spacecraft have flown over the poles of the Earth, they've felt this supersonic wind of particles called the polar wind, flowing out into space. There must be some invisible force lurking there responsible for this outflow. But we've never been able to measure this before because we haven't had the technology. So we built the Endurance rocket ship to go looking for this great invisible force, right? This ambipolar electrical field for the first time. So we were expecting to hopefully find the source of this polar wind, but what we weren't expecting was this other thing that it does to our skies and to the atmosphere, which is just so profound. There's only one launch site in the world far enough north to actually try and launch into this thing, and it's in the very north of this tiny island called Svalbard, just off the coast of the north of Norway, which meant a little bit of a trek to get it to the launch site.
About to sail today from Longyearbyen to Ny-Ålesund, up the coast for about 14 hours. We had a couple of days of being completely whited out, and now it's calm in this beautiful country. I have a feeling this might be the day.
Solar.
Solar go.
Radar.
Go.
Mission control, this is Endurance. Go flight. We are go for launch.
Yep, check 1.
I think we're about to launch a rocket.
3, 2, 1! Ignition! Ignition!
During the 15-minute suborbital flight, we successfully measured this ambipolar field for the first time. When you add up all of the strength of it over the whole flight, the whole potential drop was only about half a volt. And that's nothing, right? That's about as strong as one of those tiny little watch batteries. But that's exactly the amount that you need to explain this, polar wind escape, this outflow. Because we measured it for the first time, we can actually understand the role it plays in the atmosphere. And despite being weak, it's incredibly important. It counters gravity and it basically lifts the skies up. It's like this conveyor belt that's lifting this atmosphere up into space. So like us, you're probably left with a lot of questions, right? What does this field do? What's it for, right? How does it shape the planet? And I can't tell you yet. This field is so fundamental to understanding the way the planet works. And it's been here since the beginning, alongside gravity and magnetism. It's been wafting particles to space and, stretching up the sky since the beginning. It's probably had an impact on the evolution of the atmosphere, but I can't tell you how much yet. It may even have left a mark on the oceans, but how much I don't know. This field is a fundamental part of the way Earth works. And now we've finally measured it, we can actually start to ask some of these bigger and exciting questions.
Our solar system is home to 8 planets and nearly 300 known moons. But of those many worlds, only 2 are shaped by an active rain cycle: Earth and Saturn's largest moon, Titan. Now, NASA's James Webb Space Telescope has discovered a new molecule in Titan's atmosphere, one that may have implications for the future of this surprisingly Earth-like world. From space, Titan appears to be a featureless orange globe, with its lower atmosphere and its surface hidden by an organic haze. But when we look at the moon in infrared, its features emerge: dark dune fields circling the equator, vast plains in the mid-latitudes, and in the far north, lakes and seas rivaling the Great Lakes of North America. Unlike Earth, these bodies are not made of liquid water, but of hydrocarbons like methane and ethane, chilled to cryogenic temperatures. From 2022 to 2023, my colleagues and I studied Titan with the Webb telescope and the Keck Observatory on Mauna Kea. Their powerful infrared vision cut through Titan's haze to reveal its northern hemisphere during late summer. What we saw were 2 broad areas of methane cloud cover around 55 degrees north, close to the largest lakes and seas. In 2004, NASA's Cassini orbiter made its first close encounter with Titan while the southern hemisphere was in summer. Cassini witnessed rain clouds forming in the drier south polar regions due to seasonal heating and evaporation. Climate models predicted that as Titan's northern hemisphere entered summer, beginning in 2017, methane would evaporate from its large lakes and seas, rising into the lower atmosphere to form rain clouds. Now, our study has confirmed that when Titan's northern hemisphere warms up, it also undergoes a seasonal cycle of cloud formation. In addition to taking pictures of Titan, we used the Webb telescope's mid-infrared instrument, or MIRI, to study the makeup of its atmosphere. MIRI is both a camera and a spectrometer. It can break apart the light from an object to determine its chemical composition. Like Earth, Titan's atmosphere is made primarily of nitrogen, but it also has a substantial amount of methane, which plays a similar role to Earth's water vapor. Trace gases are present as well, including heavier hydrocarbons, like ethane, but the details of their formation are murky. Now, Webb's MIRI instrument has shed new light on how these hydrocarbons form. When MIRI measured Titan's spectrum, it saw a previously undetected spike, indicating the presence of the methyl radical, the missing link to the heavier hydrocarbons. Here's how the process works. In Titan's upper atmosphere, UV radiation from the Sun and electrons from Saturn break apart methane into hydrogen atoms and methyl radicals. The hydrogen is lost to space, while the short-lived methyl radicals recombine into heavier molecules like ethane. Ethane and methane eventually condense into droplets and rain out of the atmosphere, replenishing lakes and seas on the surface. Rainfall on Titan has yet to be directly observed, But the discovery of methyl radicals fills a gap in our observations, and it supports our understanding of this surprisingly Earth-like world. Further discoveries will come in 2034, when NASA's Dragonfly mission touches down near the equator during northern winter. Dragonfly will drill into the icy surface to look for complex molecules made from Titan's abundant methane, nitrogen, and oxygen. Of particular interest to its search are amino acids, the building blocks of proteins that make up life on Earth. As spring slowly returns to the northern hemisphere in the late 2030s, Dragonfly may also become the first mission to witness rainfall on another world. Looking ahead to the far future, our study hints at an intriguing possibility for the evolution of Titan's climate. If the methane that is being broken apart in the upper atmosphere is not replenished from the moon's interior, it could eventually disappear from the environment. Over tens of millions of years, Titan's lakes and seas could dry up. Its shorelines could gradually give way to the encroaching desert. Its rain clouds and organic haze could vanish, leaving a dark blue sky. At last, Saturn would be visible from Titan's surface, gazing down upon a world of dry lake beds, empty river channels, and endless dunes.
For the first time ever, a spacecraft has captured images of the Sun's polar regions. Most spacecraft orbit around the Sun's equator, but in March 2025, Solar Orbiter tilted its orbit to bring the Sun's south pole into view. Looking at the Sun's magnetic field, the spacecraft discovered a chaotic mix of magnetic forces. Blue and red speckles mark different magnetic polarities, like the opposite ends of a bar magnet. But this multicolored view won't last long. Right now, the Sun is in the most chaotic phase of its natural cycle. Every 11 years, the Sun's northern and southern magnetic poles reverse. That reversal is underway now, unleashing a complex mix of polarities at the poles. In a few years, the two polarities will separate to inhabit opposite poles. Solar Orbiter will be the first spacecraft to watch this flip happen at the poles, giving us information that's key to understanding how solar activity impacts us on Earth.
For 25 years, NASA has been filming the journey of the James Webb Space Telescope. This is a never-before-seen look. I'm excited for people to see the drama of what it takes to make a space telescope.
Nature has this way of being even more creative than we are. We have always been surprised by what we see in the sky. That's why building a telescope has always been interesting.
The voyage back to the birth of the universe.
These decades of work of thousands of people around the world to make this telescope possible.
Okay, gonna have lots of inventions along the way.
Now, how can we justify this to our constituents?
We're going to change how we understand the universe.
Science is a process.
All 6 metric tons of this has to be launched 1 million miles out into outer space.
Isn't that kind of crazy not to be able to service it?
And liftoff.
Yeah, that's the only choice we had.
I really wanted to honor what an incredible mission this was.
We were on edge, from blizzards to hurricanes.
There was nothing easy about Webb at all.
Constant pressure.
There was something different about this one. You knew you were in the middle of something big.
We're going to see all the way back to the very beginning of the universe, what we call cosmic dawn.